All right, so this is our next proof. It gives us ABCD is a parallelogram and angle ABC is a right angle. We need to prove that segment AC is congruent to BD. So again, what this is really telling us is that we have a rectangle. Because if I'm a parallelogram, I know that opposite angles are congruent and I know that consecutive angles are supplementary. So if B is a right angle, then so is D. And then if B is a right angle, A has to be a right angle because they have to add up to 180. 90, 90 is 180. So I have 4 right angles. My job is now to show that AC and BD are congruent. In order to do this proof, we have to use overlapping triangles. Because they gave me ABC as the right angle, I will use that right triangle. And the other right triangle I will use, and I have choice, but I'm going to choose to use this one right here. Now, in this proof, we want to prove that BD and AC are congruent. Those are going to be the hypotenuses of 2 right triangles. Because we want to prove the hypotenuse is congruent, we are not going to use HL to prove the triangle is congruent. Okay, so be aware of that. But again, this is still a triangle congruence proof. So what's going to be the justifications or the gist of this proof? Well, this will be a right angle down here. So I'll have two right angles. They share this side right here. And these two sides are opposite sides of this parallelogram. They're going to be congruent. And then these two triangles will be congruent by side, angle, side. Since the triangles are congruent, then these two sides will be congruent by CP, CTC. And that's the gist of the proof. So it's our job to make that happen. Okay? I'm going to erase all this and we'll walk through it slowly together. So again, I need another right angle. I'm going to say that angle BAD is a right angle. BAD is a right angle. And I'm going to use the fact that in a parallelogram, you have consecutive angles that are supplementary. So this one, an angle supplementary to a right angle is a right angle. So because it's a parallelogram, they are, it has not been proved that it's supplementary. So I need to say that they're supplementary first. Okay. So this, for some reason, makes you explicitly write out all of the parallelogram ideas. So be aware of that. So I need to write that the two angles, angle ABC that they give me, and the other angle BAD that I want to prove a right angle are supplementary. And this is because in a parallelogram, consecutive angles are supplementary. Nice. So now that they are supplementary, now I can say that angle BAD is a right angle because I have shown it to be supplementary to a right angle. Okay. So now I'm going to say that the two angles are congruent. ABC and BAD. Again, this is all right angles are congruent. They're right angles. We've done this before. But again, now the idea is between these two triangles, I have a pair of congruent angles. There's my angle pair. So now let's talk about BC, just one dash, sorry. BC and AD being congruent because they're opposite sides of this parallelogram. So now segments BC and AD are congruent because I'm looking for it in a parallelogram, opposite sides of a parallelogram are congruent right there. Boom, got it. And now we're going to use AB because it's in both triangles. It's the overlapping side, AB and AB. That's reflexive. And now again, what do I have marked? I have this angle pair. I just have this side, and now I just marked this side. These two triangles are congruent by side, angle, side. So the naming is important. So I'll name the first one, I'll call it ABC. So I went A, B, C. So I have to do the same thing. So I went A, B, C, watch. I went from A to B to C. So now I have to do the same thing going in the reverse order for the bottom triangle, B to A to D, BAD. All right, so that correspondence can be tricky. And this will be a by side angle side. And now in these two triangles, the two diagonals of the parallelogram, A, C, and BD are corresponding parts. They will be congruent by CP, CTC. C, PD, C, done. And the proof is done. Let me get rid of my writing. I want the bigger check mark. There we go. So again, I think this is also a difficult proof because the triangles are overlapping. All right. All right. But again, do your best to replicate this on your own. Okay, because these proofs take a little bit of time, I'm going to stop the video now and I'll do the last problem in a separate video.